Hi students, so today we are going to discuss the topic from the chapter that is compass surveying. So the subject name is basic surveying, subject code CE105. So today we are going to see the topic is various definitions in compass surveying. So in the previous class we have discussed regarding the compass surveying principles and component parts of compass. So today, on completion of this topic, you would be able to define the terms whole circle bearing and quadrantal bearing, true meridian, magnetic meridian, true bearing, magnetic bearing, declination. So these are all the important terms in the compass surveying, and the finally very important one is local attraction. So you can see here whole circle bearing, quadrantal bearing. So these are all the bearings called which are taken angles. So actually what is a bearing means, a bearing it is also called an angle which is taken in the sighting the objects, okay, which is taken as an horizontal angle is known as bearing. So let us see the one by one. So before that we have seen in the previous class the principle of compass surveying, and we have seen the traversing. What is traversing? So we have seen that traversing is a series of connected lines, and the types of traversing are also seen, that is open traverse and closed traverse. And actually what is compass we have seen, that is compass is an angle bearing measuring instrument. So these are the topics we have discussed in our previous videos. So we have seen the different types of compasses also. Those are prismatic compass and surveyor's compass. So now let us see the definitions in the compass surveying. So the first one is, what is the bearing of the line? So that is the horizontal angle made by the survey line with some fixed reference direction is bearing of line. So that means the bearing of line is called, that is a horizontal angle made by the survey line with some fixed reference direction is bearing of line. Suppose this is an angle which is a compass instrument is situated here. So we are seeing a horizontal angle, okay. So that means you can see a survey line is there like this, so which is near a canal or a reservoir or any other roadway if you are doing. So we are taking from that point and keeping the perpendicular offsets. So whatever the angle you are seeing, that is called horizontal angle, and that is also called a bearing angle. So here the horizontal angle made by the survey line with some fixed reference direction is called bearing of line. The next is the fixed reference is known as meridian. So here the bearing of the line, when you see in the direction, then here we will fix the reference is known as meridian. So there are the meridians are true meridian and magnetic meridian. So we are having these two meridians, that is true meridian and magnetic meridian. And the third one is arbitrary meridian. So what is true meridian? True meridian, it is the line passing through the point and joining the north and south poles of the earth. So here the true meridian, which is defined as, so in the direction you can see in the diagram. So here this is the north pole and this is the south pole. Here we can see the point P and Q. So here, which is the line passing through the point and joining the north and south poles of the earth, is called true meridian. So that means a line which is passing through the point. So this is the circle which is passing through the north and south pole. So a circle only can move in the north pole and south pole direction, so that it is called true meridian. Let PAQ is the true meridian. Then what is true bearing? It is the horizontal angle made by the survey line with the true meridian. So again, the true bearing is, it is the horizontal angle made by the survey line with the true meridian. That means with the help of this true meridian, the horizontal angle will be made by the survey line. So here we can see the diagram. The first one is true meridian. So the first one is called true meridian. This is north direction faced. And the next one is magnetic meridian. So this is MN. So that means magnetic north. So this is the direction where we have seen. And the next one is magnetic bearing. So this is a magnetic bearing we have seen. So next one is true bearing. So totally we are having the two bearings and two meridians. So the meridians are shows the directions and the bearings are shows the angles. So next one is magnetic meridian. The direction shown by a freely suspended well balanced magnetic needle at any point is termed as magnetic meridian. So here it is a well balanced magnetic needle at any point. So that means it is called magnetic needle meridian. So here we can see this is a magnetic meridian. And next one is magnetic bearing. So here the horizontal angles made by the survey line with the magnetic meridian. So this is known as magnetic bearing or magnetic meridian. Here bearing or meridian both are same. So same diagram. And the next one is arbitrary meridian. So here any arbitrarily assumed direction chosen to measure the bearings is termed as arbitrary meridian. Any arbitrarily assumed direction chosen to measure the bearings is termed as arbitrary meridian. And the next one is arbitrary bearing. So here the horizontal angle made by the survey line with the arbitrary median. That means this arbitrary bearing is also called an horizontal angle which is made by the survey line with arbitrary meridian. So the next is bearings are designated by two systems. One is WCB over circuit bearing and the next one is quadrantal bearing or registered bearing. So QB or RB, quadrantal bearing or registered bearing. So here whole circle bearing, the bearing of a line measured from the north in clockwise direction. So the value of whole circle bearing varies from 0 degrees to 360 degrees. So here the bearing of a line measured from the north in clockwise direction, the value of whole circle bearing varies with 0 degree to 360 degrees. The next is sketch of whole circle bearing. So this is a whole circle bearing diagram. So observe so here you can see this is A, B, C and D. So we are having 4 station points. So the first one is whole circle bearing of OA is equal to theta 1. That means this is the first O. So for this we have to find out the whole circle bearings. So the next one is whole circle bearing of theta 2 is equal to OB is equal to theta 2. This is the theta 2. So it is in the clockwise direction and theta 1 also. Then whole circle bearing of OC is theta 3. And the next one is O4. So we are having quadrantal bearing or registered bearing. The bearing of a line observed either from the north or south. So it is measured in clockwise or anti-clockwise direction. So towards east or west, the value of QB ranges between 0 degrees to 90 degrees. So quadrantal bearing or registered bearing. So here the bearing of line observed either from north or south and it should be measured in clockwise or anti-clockwise. So towards east to west and the value of quadrantal bearing ranges between 0 degrees to 90 degrees. Sketch of reduced quadrantal bearing. So this is the quadrantal bearing diagram. So here we will show the direction. Registered bearing of OA is equal to n theta 1 degrees E. So this is the n theta 1 degrees E. It is started from north n. So it is the positive direction where is we can see here, and RB of OB is equal to S theta 2 E, and this is the second direction in B, and RB of OC is equal to S theta 3 degrees E. So this is the third direction, and RB of OD is equal to N theta 4 degrees E. So that is the fourth diagram. So the first one will be this one A, and the second one this, and the third it will be of S theta 3. So this one is third, and fourth one OD is equal to theta 4. This is 4, that is in the north direction. So here some of the rules are there. For conversion of bearing from whole circle bearing to quadrantal bearing, it is also called reduced bearing. So when the line lying in first quadrant, so what is first corner like this? So this is the first quadrant. So it will be the 0 to 0 degrees to 90 degrees. And rule for conversion quadrantal bearing is reduced bearing is same as whole circle bearing. So the quadrant will be north east. And the next one is 90 degrees to 180 degrees. Here we have to do, if the whole circle bearing is more than the reduced bearing, then we have to do minus with 180 degrees. So that is equal to RB is equal to 180 degrees minus whole circle B, that is southeast. And the third one 180 degrees to 270 degrees. Here reduced bearing is equal to whole circle bearing minus 180. Then the quadrant is southwest. And fourth one 270 degrees to 360 degrees. The reduced bearing is equal to 360 degrees minus whole circle bearing, that is northwest, southwest and northwest. So in reduced bearing, quadrantal bearing to whole circle bearing, let us see the conversions. So this is also same as like that. So this is quadrant in which survey lies, and whole circle bearing between reduced bearing, lying between reduced bearing, rule of conversion to QB, rule of conversion whole circle bearing, and quadrant WCB lying between 0 degrees to 90 degrees, 90 degrees to 180 degrees, 180 to 270 degrees, and 270 to 360 degrees. So we have to follow these rules compulsory in the compass survey calculation. So declination. What is declination? The horizontal angle subtended between the true meridian and the magnetic meridian. So the declaration is, it is a horizontal angle subtended between the true meridian and magnetic meridian. Let us see. Here we can see the diagrams. In this diagram, this is left one is declination west. So this is magnetic north, true bearing, magnetic bearing, declination waves. So this declination west. So this is the declination west angle, and next one is declination east, that is Tn, Mn, and declination east, true bearing, magnetic bearing. So this is the horizontal angle subtended between the true meridian and magnetic meridian. So here true meridian and magnetic meridian will be the east, and in magnetic meridian and true meridian it will be west. If the magnetic meridian is towards east of true meridian, the declination is east. So here, if the magnetic meridian is towards east of true meridian, the declination will be east. So this is the magnetic north, true bearing, magnetic bearing. And this is declination west. So it represents west declination and it is east declination. So here the relation between the true bearing and magnetic bearing of a line can be written as true bearing is equal to magnetic bearing plus or minus declination. So here the true bearing is equal to magnetic bearing plus or minus declination. So for each declination, so this is the next one. For each declination there will be positive sign is to be used, whereas negative sign is used for west declination. So true bearing is equal to magnetic bearing plus or minus declination. So magnetic bearing is similar to true bearing plus or minus declination. So this is the magnetic bearing calculation. So it will be the true bearing plus or minus declination. And for east declination, negative sign is to be carried by west declination. So here for east declination there will be negative sign to be used, whereas negative sign is used for west declination. So the next diagram is local direction. Local attraction is the important thing. A magnetic needle increases the north direction which when freely suspended or pointed. So here a magnetic needle indicates the north direction because of it should not keep the freely suspended particles or items. And sometimes the needle comes near some magnetic substances such as iron ore, steel, electric cables, conveying current, etc. Sometimes the needle comes near some magnetic substances such as iron ore, steel such as electric cables, conveying current, etc. So here local attraction. So then it is found to be deflected from its true direction and does not show the actual magnetic north. So this disturbing influence of magnetic substances is known as local attraction. So here it will be the disturbing influence of magnetic substances. So it is called local attraction, which will be affected by the instruments, chain, nearby obstructions, people. So if here all the lines of a traverse are found to be affected by local attraction, Then the line with minimum error is identified. The forward bearing and back bearing of this line are adjusted by distributing the error quality. Then starting from this Adilabad line, starting from this adjusted line, the force and the back bearings of other lines are corrected. So these are the survey lines which will be found in the or to be affected by local attraction. So summary, the angle between the true meridian line is known as true meridian. So the angle between the magnetic meridian and the line is known as magnetic bearing. So the angle between the arbitrary meridian line is known as arbitrary bearing. So, and whole circle bearing is measured clockwise from north. So quadrantal bearing is measured clockwise or counterclockwise from north to south. So whole circle bearing values from ranges from 0 degrees to 360 degrees, and quadrantal bearing ranges from 0 degrees to 90 degrees. The distributing influence of magnetic substances on a magnetic needle is known as local attraction. So this is our local attraction details. The horizontal angle between the true meridian and magnetic meridian is known as declination. So what is it? The horizontal angle between the true meridian and magnetic meridian is known as declination. So true bearing is equal to magnetic bearing plus or minus declination. So magnetic bearing is equal to true bearing plus or minus declination. So this is to know the magnetic bearing temperature. Here we can see true bearing plus or minus declination. So these are the important terms used in the compass surveying. So let us continue here. On whole circle bearings, here some of the examples were given. Objectives. On completion of this topic, you would be able to know convert one system of bearing into other system. That is from whole circle bearing to registered bearing. So once we see the whole circle bearing is, it is measured from north pole in clockwise direction, and if the survey line is first quadrant, QB is equal to WCB, and if the survey line is in second quadrant, QB is equal to 180 degrees whole CB, and if the third survey line is in third quadrant, quadrantal bearing is equal to whole circle bearing minus 180, and if the survey line is in fourth quadrant, quadrantal bearing is equal to 360 degrees minus whole circle bearing. So what is quadrantal bearing of 75 degrees? It is in the first quadrant. Quadrantal bearing is equal to horizontal bearing. So let us see the problems in whole circle bearing. Convert the following whole circle bearing into quadrantal bearings. So first one is A 70 degrees 20 minutes, B 130 degrees 30 minutes, and C 20 degrees 80 degrees 30 minutes, and D 232 degrees 30 minutes. So we have to convert them into whole circle bearing into quadrantal bearings. So they are in the generally as per the directions we have to draw. So the first one is 78 degrees 20 minutes. It is in the first quadrant. So this is the direction we have shown. and here 78 degrees 20 minutes it is in first quadrant. So here WCB is equal to QB. And the next is so here we can see the diagram important points. So 78 degrees 20 minutes is equal to 978 degrees 20 minutes east. So here this is the quadrantal bearing. You can see we are 1 2 3 4 zones. So 130 degrees 30 minutes is in second quadrant, suppose. Then here quadrantal bearing is equal to 180 degrees minus 4 circle bearing is equal to SC. So that is quadrantal bearing is equal to 180 degrees minus 4 circle bearing is 130 degrees 30 minutes. 130 degrees 30 minutes is equal to south, 49 degrees 30 minutes east. So it is a second quadrant which is given, that is 130 degrees 30 minutes is the second quadrant. And the next one is 280 degrees 30 minutes. It is in fourth quadrant. Quadrantal bearing is equal to 360 degrees into minus whole circle bearing minus 360 degrees minus 280 degrees is equal to 79 degrees 30 minutes west. So here we will write it is in north 79 degrees 30 minutes west. So it shows the directions, the B. So here now again 232 degrees 30 minutes is in third quadrant. Then quadrantal bearing is equal to whole circle bearing minus 180 degrees is equal to 232 degrees 30 minutes. So it will be more or near the 180 degrees, more than the 180 degrees value, so that we will do the minus of 180 degrees. Then we will get yes 52 degrees 30 minutes west. So now let us convert the following whole circle bearings into reduced bearing. The first one 42 degrees 15 minutes, 223 degrees 15 minutes, 322 degrees 30 minutes, 142 degrees 30 minutes. So here 42 degrees 15 minutes is given, so that is in the first quadrant. Okay, and next is 4 circle bearing is equal quadrant bearing, that is 42 degrees 15 minutes is in first quadrant. Then quadrantal bearing is equal to north 42 degrees 15 minutes east. We have to write like that. And the second one is 223 degrees 15 minutes. So it will comes from north here in direction. This is the 223 degrees 15 minutes. So this you have to calculate is in third quadrant. So quadrantal bearing is equal to 4 circle bearing minus 180 degrees is equal to 232 degrees 15 minutes minus 180 degrees is equal to, this is S 43 degrees 15 minutes west. So that means here the south direction 43 degrees 15 minutes and west. And the next one is 322 degrees 30 minutes is in fourth quadrant. That is quadrantal bearing is equal to 360 degrees minus whole circle bearing is equal to 360 degrees minus 322 degrees 30 minutes again now. So here this is the north 37 degrees 30 minutes west. And the next one is 142 degrees 30 minutes. So it is in the second quadrant. So quadrantal bearing is equal to 180 degrees minus whole circle bearing is equal to 180 degrees minus 142 degrees 30 minutes. And the quadrantal bearing is south 37 degrees 30 minutes east. And next, convert the following four circle bearing into reduced bearing now. So A 287 degrees, B 107 degrees 45 minutes, and C 12 degrees 45 minutes, and D 180 degrees 15 minutes. So right here, so the first one is 287 degrees. From first it shows to the last of the fourth quadrant. So it is in the fourth quadrant. Quadrantal bearing is equal to 360 degrees minus whole circle bearing, because it is nearer to the 360 degrees, so that's why we have to do with the 360 degrees. So by removing 287 degrees from 360 degrees, we will get north 73 degrees west. So the next one is 107 degrees 45 minutes. So here it is in also second quadrant. So quadrantal bearing is equal to 180 degrees minus whole circle bearing is equal to, that is 107 degrees 45 minutes. So quadrantal bearing is equal to south 72 degrees 15 minutes east. The next one is 12 degrees 45 minutes. So it is in the first quadrant. So whole circle bearing is equal to quadrantal bearing. That is quadrantal bearing is equal to north 12 degrees 45 minutes east. So next, the last one, fourth one is 193 degrees 15 minutes. So it is in the third quadrant. 193 degrees 15 minutes is in the third quadrant. So quadrantal bearing is equal to whole circle bearing minus 180 degrees. That is quadrantal bearing is equal to 180 degrees 15 minutes minus 180 degrees is equal to south 13 degrees 15 minutes west. So now next, convert the following whole circle bearings into reduced bearing. A 50 degrees, B 230 degrees, C 105 degrees 30 minutes, and D. So these are the discounts which will be available. So next one is 325 degrees 30 minutes. So here the first one, if you see, it is the 50 degrees there. So it is in first quadrant, and whole circle bearing is equal to quadrantal bearing. So that is quadrantal bearing is equal to north 50 degrees east. So 230 degrees is in third quadrant. That is quadrantal bearing is equal to whole circle bearing minus 100 degrees. And quadrantal bearing is equal to whole circle bearing minus 180 degrees. And quadrantal bearing is equal to 230 degrees minus 180 degrees. Quadrantal bearing is south 50 degrees west. So this is the regarding calculation of, and this is the last coordinate, that is 145 degrees 30 minutes. So it is in second quadrant. Quadrantal bearing is equal to 180 degrees minus whole circle bearing. So quadrantal bearing is equal to 180 degrees minus 145 degrees 30 minutes. That is quadrantal bearing is equal to south 34 degrees 30 minutes east. So this is the next one is 325 degrees 30 minutes. It is in fourth quadrant. So we have to think quadrantal bearing is equal to, first is 360 degrees minus whole circle bearing, and quadrantal bearing is equal to 360 degrees minus 325 degrees 30 minutes. So quadrantal bearing is equal to n 34 30 minutes west. So convert the following whole circle bearing into reduced bearing. So the next one is 289 degrees 27 minutes. It is in fourth quadrant. So it is equal to 360 degrees minus whole circle bearing, and 360 degrees minus 2897 minus, and the quadrantal bearing n 70 degrees 33 minutes west. So meanwhile, like this 109 degrees 27 west. So I think everyone have understood up to here. So we will continue in the next class.